Hi guys, just going to continue with 1.1, just looking at functions. Second video, the first video I left out domain and range, so let's go over this after we've sketched those few sketches also. So domain, if you go back to the definition of domain and range. So this was the definition. I don't think I wrote this down on the last video, but you have a relation is an identified pattern, and a function is where no two ordered pairs have the same x value. So that was a horrible job of the highlighting. It's actually the worst highlighting I've ever seen. So let me try that again. So let's go back right here. Okay, so if I was to highlight, right. All right, so no ordered pairs have the same x value. That's a function, so we talked about that, okay. You don't have repeated x value. But we didn't really get to this domain and range. So domain and range, the domain is all the possible x values or independent values, and a range is all the possible dependent values. So when you have a function or a relation, and you look at the domain, it's all the possible x values that exist, and for range, it's all the possible y values that exist. So like a lot of things, let's look at some examples to simplify this. So if we go here, where we have points, we have a series of points. So this is what we'll start with, a series of points here. And if I have these points here, the domain is all of the x values. So all these are x and y points. So I have a -3, I have a -2, I have a 5, and another 5, and a 6. So what we do is you write them out here. What you do is you use set notation. Set notation looks like this. Okay, not really, but it's a bracket that has a little curve to it. And when you write a set, this means this is a set. Okay, set notation means a set, and then all the elements in the set are separated by commas. So when you write set notation, you want to talk about the domain. D stands for domain. The domain is all the possible x values here, and we saw a -3, we saw a -2, and we saw 2 5s, but we only write that once, okay? So we don't write the 5 twice, and then we also could be a 6, okay? The range here is going to be all the possible y values. So we would like to put these in order so we keep track. It doesn't have to be in order, but it would make more sense if it is. So the smallest y value was -8, so that goes there. We also have a -6, a 3, a 4, and a 7. So we'll write these again with set notation. And here we ask ourselves, is this a function? Well, this is nice to look at because what you have here is if your domain is smaller than your range, then that means you have to repeat an x value to get a y value, okay? And so this is not a function. And the reason it's not a function, it goes back to what we were looking at, talking about with the repeated negative or positive 5s here, is that here we have 5, -6, and here we have 5, 3, and together you have 2 5s that give you different values. So what's happening is you have a situation where you throw 5 into an equation, and you get -6, you throw 5 and you get 3. And if you were to graph those points, you'd have 5, -6 would be somewhere down here, and 5, 3 would be here, and you'd fail the vertical line test. Okay, so there's repetition. It's not a function, and that's that guy here. We look at the same thing here. We have all the ages and all the numbers, and then you look at the domain. You just go ahead and you list all these, and you list the range here. And is this a function? Yes, it is a function. And it would be a function. Let me just see something here. Do we have any repetition? Even if you repeat it here. So I think we use a different example sometimes where you have something like this, where you might have 5 twice. So you have a 5 here and a 5 here. That's fine, right? Because what's going to happen here is that you would have age. So if you had age on the bottom and number going this way, you would have 5 6-year-olds. So if you had 6-year-olds, you have 5 of them. And then when you got to 9-year-olds, you also have 5, and which is totally fine, right? If you were to keep track of this and look at points here, you can have 5 6-year-olds and you can have 5 9-year-olds. The issue with it being not a function is a repetition in the independent variable. So if this was a 6 and you had 6 here, you had let's say it's 6, 8 here. How old are the kids? 6 years old, and there's 5 of them. How old are the kids? 6 years old, and there's 8 of them. That makes no sense. That's a mistake. Okay, so that's not a function because it in real life, again, I mentioned in class, functions are what you see in real life when it comes to all the different problems we're really concerned with. That's why this course is called Functions, because we're concerned about functions. Hence the name of the course, Functions. All right. Anyway, back to this stuff here. We're going to talk about domain and range of graphs. So this is all weird. It'll make sense here. So give me 2 seconds. Once you plot this, you get this off Desmos, and you plot this. That's your line looks like this, and you have arrows on both sides here. So when you have a situation where you have a line and there's any possible value, there's every value of x is possible, and then because it's a function, every value of y is also possible. So when you graph this, we can go in the x direction this way, the x direction that way. We can go up, we can go down. Everything's possible. And when we talk about the domain there, the way we talk about it is we say that there's no limit to the domain. So that means x can be any real number. So x is any real number. So I usually write it like this. This is a little fancier with the double line on the R here, which is better. But so you write here D for domain. The domain is x can be any value. Okay, any real number. And same with y. There's no limit to the y value. There's no up or down limit. So we just write it like this. Y belongs to the set of real numbers. Y can be anything. Okay. So it's any value. We're talking about real numbers in class, but that's how you write that. If there's a limit, then you have to deal with it. So for this guy here, where we have a quadratic relation, we plot this, and then this guy here is limited. Okay, and we talked about this in the past. This is going to have a minimum. Okay, so this will have a minimum. And it gets down to 3, and that's it. So we look here and we say, let's look at domain, which is the x value. There's no limit to where we're going side to side. I know it looks like we're getting steep here, but there's nothing stopping us from going to, let's say 10 or 10,000 or negative 17 or whatever, okay? So again, no limit, so we just say domain is x is a real number. There is limit to the range, though. And to write this, what we start off and we say y is a real number, okay? But then we're going to talk about the restriction. So you can put a comma. Sometimes I put a line like this. Okay, you'll see it written like this. You'll see this also swapped sometimes. So you can even see something like this, written like this, y hat, and then you write the restriction first, and then you talk about it being a real number. But let's get to this first and explain it. So y is a real number. That's fine because this is a line, so any value exists. But there are limits to it. So the limits are that y has to be bigger than 3. We have no values less than 3. So all of these values of y down here don't exist. So we say y has to be bigger than 3. So what we say is the range is that y is a real number or belongs to the set of real numbers where y is greater than or equal to 3. Now we use the greater than or equal to most of the time. Sometimes it'll be just greater than or less than, but most of the time it'll include the equal to because 3 is fine here. So we can get down to 3. And we have to stay above 3. So it's the minimum value is 3, but it does exist. That's why there's the equal part here too. Okay, but most of the time it'll have the equal when you have an inequality there. This guy here looks like that. Okay, so we'll talk about that later, how to plot these, right? But that's what it looks like. So now once you have the graph, you can get the domain and range of any graph. It doesn't even have to make sense to you. You don't even have to know where it comes from. And here you say the domain is x is a real number. So now we look at it and we say, okay, it's a line. So x is a real number. Good. And there's a limit here. X can't be over here. Okay. But we, like in our brains, we talk about what it can't be. But when we talk about the restrictions, we talk about what it has to be or what it can be. Very positive people. So x has to be at least 1 and it can be bigger than 1. So that's x is greater than or equal to 1. Anything here is fine. Let's talk about y here. Y can't be less than 3. Or as we say here, y has to be bigger than 3 or equal to. Okay, so we say y is a real number and y is greater than or equal to 3. It gets a little more complicated with things like this, a circle. So when you have a circle, this is not that difficult once you get it written down. But this circle kind of goes to 5 and negative 5, 5 and negative 5. And every value between 5 and negative 5 is fine. And the way we write this is we say that x is a real number. And I'm going to show you how we write this. You write the smallest value here, the biggest value here, and then x, and then less than or equal to, less than or equal to. So x is between negative 5 and 5. So negative 5 is less than or equal to x, which is less than or equal to 5. That's how we say that, okay? So x is between negative 5 and 5. and that's how you write that. Same with the y value here. You'd write it like this. So you would say y is between -5 and 5, and that's how you write the range. Now be careful. Remember, domain is x and range is y. And the last one is a little different here. This has what we call asymptotes. So if you plotted these on Desmos, you notice they can't go here and they can't go here. These are asymptotes right there. And what happens is x can't have a value of 2 and y can't have a value of 0. So that's from the graph. We'll talk more about that later, but let's just deal with the domain and range here. When you deal with this, in this case, you actually, I said we use the positive, but we're talking about what it can't be. So when you have an asymptote, you say what it can't be. So x is anything but not 2. X is anything but not, or sorry, y is anything but not 0. So domain is x is a real number, but x can't be 2. And the range is y is a real number, and y cannot be 0. So there, that goes with that, and that goes with that. And that's how you write those. Okay, so that's domain and range, and that's the whole note now. All right, take care.